And just to recap, we were talking about SCM, and I gave you this formal definition of SCM, which is the control of the evolution of complex systems. And this definition is pretty complex. So, in layman, we want to know what it is, which is basically managing change in software projects. Okay? And I guess I gave you the very broad, fictitious motivation behind why we want to do SCM with the moving target problem. But more specifically, or more realistically, in software engineering or software projects in general, we have several issues that lead to why we want to do SCM in a very disciplined and a formal manner. Okay, so for example, you as a developer of a team, a software team, is working on code that resides in a repository online of all your code files and other files. And then at some point of time, somebody else may be working on the same files and introducing bugs into your code. And then somebody else again, maybe this time a lady, okay, is assigned to fix this bug. Okay, so her role is to check out the code and fix this bug. While your original role was actually to do up version 2.0 of the software. Okay, and so this is one issue that, when you have multiple developers collaborating on the same piece of code, trying to work in parallel. So how do we enable that? That's one thing. And at the same time, other changes are being introduced like bugs or even new requirements, okay, which may happen at any time, which maybe the most frequent time it would happen is during sprint reviews, for example, or user evaluations, okay. And then there are many other things, new hardware, new chipsets that are being introduced by Intel and whatever not, okay. And so all these changes would impact, how you would do development, and if not managed properly, might lead to your team's detriment. Okay, and then there is the impact of money. Okay, or the cost of change. Okay, the cost of change, and I guess at some point we saw this graph at the early parts of this module. The y-axis is the cost. The x-axis is actually the phase of development. And as you move from requirements to design, to implementation, to testing, and deployment, maintenance, and so on, okay? The cost actually gets exponentially up, okay? Especially at the end phases where this costs a lot of money to change, okay, and this is very very much bigger than the cost to change over here, okay. So that's basically the motivation in software projects, why we want to do this managing of change properly, which in general, this process in software engineering terminology is called software configuration management. All right. And this consists of various things that we want to enforce or do properly, as shown over in this aggregation UML diagram over here. All right. Which involves configuration item identification, and this is basically where the name comes from, software configuration management, okay, configuration items. And then there is change management processes that needs to be put in place, and then there's also version management processes and release management processes, which are sort of related to each other, which has to be put into place very carefully as well, because these two things basically involves your code, okay, plus other configuration items. Okay, so what are these configuration items? If we go back to the first thing that we need to enforce as part of SCM, configuration item identification. All right, so this configuration item examples are here, what we are very familiar with: source code, test code, config files, and other code related files. Okay, and speaking of config files, just to get the terminology a bit clearer, because I myself find that this term called config item is a bit misleading and confusing, and it is in fact not just configuration files like the .gig ignore or other configuration files that is required for installation. And for example, this term called configuration item actually encompasses all these things over here, including all the things that we just mentioned, as well as the documents that we have churned out as artifacts of all the phases that we have done. For example, requirements, design, and tests, as we have now should be become very familiar with by now. Okay, so other than documents, there are also stuff like online wikis, things to tell users about what your apps are about, as well as instructions on how to properly install your apps. Okay, so stuff like that. All these are considered configuration items because they are sort of represents a certain state of your development. Okay, so I have this question here: what to track? All right, so we have so many things to track. Certainly, we don't want to track every single item that is out there. So actually, the question is what not to track. It's easy to say, okay, I want to track every single thing that is involved, associated with my project, maybe including employees, salaries, and so on, which is totally not actually necessary. So the question maybe should be what not to track. All right. So the things that are commonly not tracking, I mean, we shouldn't be tracking, is that things like personal config files. Okay. For example, your IDE. Okay. You might have a certain, color preference for things, okay, like syntax highlighting and so on. So these schemes are actually private to you, and there's no need for you to put it up as a config item to other people who wants to keep track of what's happening. Okay, in fact, if you do that, people will get annoyed with you. Another things that people might get annoyed with you is if you add auto generated generated files. Okay, most often also related to IDE project settings. Okay, and other things are like compiled binaries. Okay, for example, exe files, .app files, and so on. Okay, these are things that are not meaningful to track. Okay, you want to track source code for this purpose rather than the exes. And similarly, very large forgot the asset files. Okay, especially if you are familiar with Unity or game development in general, there's a lot of files that are huge. Okay, your model files. Okay, and the source model files are especially huge. Okay, other files in general, even for these web projects and so on, there are huge image files and so on. Okay, so these are files that people do not commonly track, but some people, some organizations or teams might still want to track some of these asset files, and there are special tools that allows for us to do that, because without these special tools, actually it may hinder our development by making all this available to everybody, and every time there's a small change to your bitmap design, 1 pixel change, everybody else needs to download that whole 1 GB file in order to merge your current development, okay, or in order to fetch the latest current development status. Okay, so all these things, right, commonly if you're using a tool, you are able to specify them as part of a config item. I do not confuse the term, a configuration file, I mean. Okay, for example, in Git, okay, or GitHub, uh, in general, we have this git ignore file that allows us to specify every single thing that we do not want to track. Okay, but we'll come to version control soon. Now we are still trying to identify what to track and what not to track. Okay, so the other question is when to track. And the answer for this is actually all the time, from the start to the end of your project. Okay? And if the project or the software belongs to your own company, maybe this never ends. Okay, there is no such thing as the end of the project. But if you were a vendor, okay, if you were a vendor, you would actually have an end, so you need to track all the way to the end, and you hand over to the product owner. Okay, so this is determining what to track and what not to track. Okay, and then we come to the other process, or the other component of this SCM process, that we need to include as part of good management of change, which, as the name implies, change management is this process that has to be in place. This process might be facilitated by software, or it might be facilitated by forms that we have seen here, which are pretty maybe more traditional. Okay, so what is this change management? Okay, firstly, introducing another diagram over here. Okay, so this diagram that we are seeing over here is basically UML flow chart, okay, which is quite intuitive. Okay, it's similar to your state chart, and I think most of us have seen flow charts before, so there's no need to specifically describe all this. But basically, there are action nodes, there are decision nodes, and so on. Okay, so what is this process of change management that we need to enforce? So note that this is just an example of a process that is typical, but not always the case that you have to have all these elements in place. Okay, but as an example. So firstly, you identify items for change. Okay, and the person who determines that a change is required is normally called the change requester. Okay, so the change requester determines that a change is required, and then he will identify all the items that are supposed to be changed. Okay, whether it is documents or source code and so on. Okay, so you need to identify all the items that are related, config items, in fact. Okay, configuration items that are supposed to be part of this change, and then you write all of that inside some form or system, and then submit the change request. So once that is submitted, somebody would do a sanity check. Okay, and check whether this is complete. Okay, by looking at so the fields here, and see whether everything makes sense. Okay, if it doesn't make sense, then you need to come back to this identifying things stage again. Okay, otherwise, if everything makes sense and this is a proper change that should can possibly be implemented, we go on to a formal process of analyzing the change. Okay, and this analyzing of the change is normally done by somebody known as the change manager. Okay, change manager will do this reviewing of the change request. Okay, reviews. And what is in this review process is that it involves looking at both technical and business impacts. Okay, which consists of examples like consequences of change, benefits of change, who is being affected, and what type of users are being affected, the cost involved to develop this change, as well as how it impacts your release cycle. At which point did this change come in? Is it like during implementation, and then so how would it affect now your timelines? Okay, so once everything is considered carefully, okay, the investigator, or the change manager, would fill in all these things over here, okay, and suggest some cost, okay, or I mean suggest some action to do, okay. And if the action is yes, okay, that means it's feasible, yes, then you will go on to assign a certain developer, which will be known as the implementer here, okay, and so on. And I've given this example of form because it's just a very formal, nice way to show how traditionally it is done. It is actually from an actual source, okay. And of course, this looks like a very uh, rigid process, okay. But as we know, if we depending on our nature of the project, as well as our team's nature, this may change. Okay, so assign developer, and then the developer would of course implement the change. It might be number of developers or one developer. Implement the change and verify that the change is okay. Once its implementation is done, okay, somebody would verify the change is okay. Probably another developer, okay, who will review the change, okay, the implemented change to be specific. Okay, this is not the request, this is already done with the implementation, and then you do the review. Okay, if review and the change is fine, it matches what is supposed to be the goal of the change, and the change is basically done of good quality, then yes, and we'll reach the end of this whole flow and come to what we know as a baseline. Okay, so what is this baseline? Okay, baseline is basically a common terminology to say that this is a point, a checkpoint for us that says that this config item is formally reviewed. Okay, so this is basically a config item that is formally reviewed, okay, and pretty much it can be like treated as a stamp of approval and say that this is now version 2, and we any thing that we want to fall back on, we'll fall back on first version 2, okay, which is supposedly the most recent approved version. Okay, so that is called the baseline, and we are increasing the baseline once the change request is considered done. So based on that, which SDLC model is this workflow suitable for? Okay, I guess because of the forms that are introduced, probably you would say waterfall. Okay, but in fact, this workflow in general is also crucial for agile changes as well. But in agile, as we know, we always like to do things with a focus on development. Okay, so we want to focus on development, and therefore this change request process is normally simplified or streamlined, okay, to sort of conform to agile principles, the manifesto. And what this means is that, for example, it is integrated into sprint reviews. Okay, so it's integrated into the sprint review meeting, and so sprint reviews, we would determine what is the changes to be made, and then crafted into user stories and so on. Okay. And also, for example, you can also use tools like Jira to help you manage change requests in a very streamlined manner. Okay. All right. So this is the change management process. Next, we will go on to these two big things. Okay. Which is version management as well as release management, which are related. Okay. Because basically, versions or release is a type of version, okay, a type that is distributed to public users. Okay, releases are basically a type of version that is released to public users. Okay, and the fact that it is released to public users, it means that it may include additional config items. Okay, so other than the source code, the executable, okay, you also have the installer package or config files to determine how this is going to be set up automatically on Mac OS architecture versus a Windows versus a Linux architecture, and other things. When you distribute software, you have to have an app page that tells people how to do this and that, okay, and so on. All right, so this is the complete package of a release, okay, or rather this is an example of what other config items that might come with a release versus just a version of your app. Okay, so and we can see that there are different goals that are supposed to be targeted towards, okay, for version management versus release management. So for example, version management, we are tracking different versions of config items, okay, that's our main goal. Whereas the slight difference in release management is that we are trying to track the history of releases, okay. So maybe I'll change the color. So here we are trying to track a history of releases, okay. And secondly, for version management, okay, we need to enable the resolution of conflicts. And thirdly, we need to enable collaboration when we are developing. Whereas on the other hand, for release management, we want to enable this hotfix process that should allow us to quickly fix bugs after release. Okay, why this is separated from the normal like version management is that because here it needs to be hot. Okay, it's hot on our heels because it's released. People expect that it works properly. So once there are bugs, we need to quickly branch off and fix it and then push it back into production. Okay. All right. So if we focus on version management first, an example of a version management process that is enforced using a tool is as such. All right. So here we can see that we start with what is so-called a development branch, okay, of our code. And everybody would assume that everybody starts off with this baseline code over here, version 1. And then a developer, for example, yourself, okay, is responsible for features. Okay, so you would keep developing new features, like for example, develop a feature A, and then you label it as version 2 in the development branch. Okay, and so on. All right. Whereas somebody like your teammate over here, she's responsible for investigating better ways of implementing the features. Okay, so at this point in time at version 2, okay, you guys would split, okay, which means that you, of course, you're working on the main development branch, would keep going, whereas for her, she will need to branch off into a variant, okay, in which she develops her own testing, not testing, but develops her own variant of feature A for, in this example. Okay, so she'll branch off and call her branch be 2.1, and then she will go on to work on her stuff. Maybe she determines that feature A needs an additional argument to make it work faster with less memory, for example. Okay, and then once she's done with that, she labels it as version 2.2. Okay, whereas in your case, you continue working on new features. You go on to add feature B in version 3.0. Maybe some other guy would branch off and investigate better ways to do feature B, but you continuing and eventually reaching version 4 with feature C. And at this point, because before you reach version 4, your teammate has actually finished with the optimal feature of an optimal version of feature A. So therefore, she will initiate or implement a merge, okay, which will merge her changes here. Of course, after checking that it is indeed faster than the original feature A, then you guys would merge, and then everything would become one again. Okay, and so on. So you can see that this process basically illustrates first, we are able to track versions, okay, which is number one over here, track different versions of config items in parallel. Okay, so track different versions in parallel. And then we are able to resolve conflicts, okay, because here we see that there is a feature A over here, you have your own feature A, so there should be a way for you to easily resolve conflicts in this commonly known as merge process in whatever tool you are using. It's probably called the same name. All right, and then it enables collaboration, as we have seen here. Yeah, you can both be working parallel, okay, on new features as well as bug fixes, or basically improving the performance of certain features. All right, so this is version management, okay. And next we have this release management, okay, which is a slightly different process, because here our goal is to enable first tracking history of releases, and secondly development of quick fixes, okay, because this is like supposed to be production code. So normally we will be working on a branch called master or production branch, okay, versus the development branch. So here all the code that is committed here should be working as best as possible, okay, or in other words, in release state. As you have seen, the coding convention here is R. All right. So for example, when we're starting off with this baseline R 2.0, we have some good code and we have some unknown bad code that has bugs, okay, and then somebody reported, put up a ticket for a bug. So somebody has to now branch off this into a hotfix branch, okay, hotfix, okay, okay, this is not a good highlighting. Highlighting is not a good way to write. All right. Okay, so the hotfix branch, okay, bug fix branch, whatever it's called, will now branch off and then do the fix. Okay, so we call it F 2.0, and we will fix things here. Okay, remove the bug. Okay, and put good code in there. Okay, and then we go to 2.1. And once we have the good code, immediately we want to quickly merge it back into our production after, of course, a review process. Okay, so now we have a new R 2.1, okay, that is has the fixed code, all right, and so on. Okay, so as you can see, right, version management and release management have pretty much very similar things that need to be enforced. So which is why both of these things are common features that you get from what is known as a VCS, okay, or version control system, okay. So version control system, okay, which should be the most popular way to refer to things like Git, okay, and SVN, and the old CVS, which we shouldn't be talking about anymore now, okay. And basically the difference between the two most popular things is either you choose to be centralized, okay, or you choose to be distributed, okay, which basically just means that everybody in the centralized server works on the same repository, while for the distributed case, where's the hands, okay, for the distributed case, everybody has its own copy of the repository, and then finally merge, whenever they are done, then they merge with the central repository, okay. We shouldn't be called central repository, because there shouldn't be such a notion in distributed, okay. So it is basically like a peer-to-peer kind of a code management system, okay. So both methodologies, distributed and centralized, are still widely adopted, okay. Like for example, centralized is pretty much still used by Google, and distributed is used by stuff like Linux, open source development, and so on, okay. So but for our purpose, we will choose to use Git, okay, because it fits a lot of the projects that we are going to do in school, okay, and it fits small development teams, actually large development teams as well, because it was made by Linus, right, as in the creator of Linux, okay, meant for large open source projects. but it also enables us to do a lot of small team work nicely as well, especially when we have teams working together as one. Okay, so below is a particularly good series of videos. Note that this is a playlist, okay, of YouTube videos, okay, made by people from Georgia Tech, okay. It was originally distributed by through Udacity, the MOOC platform, and you should take a look at them so that you can get familiar with what Git is. Git is distributed CVS, sorry, distributed VCSs are actually a bit harder to wrap your head around how the different processes work. So it's good to look at the videos and practice, and try and see how this whole workflow is in order to do nice collaborative development.
Oh, um, sorry about that. I was watching myself on YouTube. And thanks for watching this video as well. I hope you learned something in software configuration management from this lesson. So if you want to know more, since we spoke about how change management is actually absorbed into the Agile process itself, if you're applying change management to Agile, you can actually watch the remaining of the Scrum series of videos by clicking on here. And to subscribe, please click on this guy over here.